Hi everyone, welcome to my review of the Physics Toolbox Sensor Suite app. This app is packed with tools to measure motion, light, sound, and more. But today, I'll focus on testing its linear accelerometer feature. I'll show you how to access the app, explain its features, perform an experiment to test its accuracy, and give it a final rating out of 5 stars. Let's get started. Hey guys, I just forgot to mention that my name's Alexander Naar, and I'm a senior in Mr. Papako's 12th grade physics class, and this is my project that I'm doing for his class, and I'm posting it publicly on my YouTube channel called Pockets, so make sure to subscribe to see the more upcoming physics projects. To download the Physics Toolbox Sensor Suite app, just search for it on your device's app store. It's completely free and available on both iOS and Android. Once you download it, the interface is simple to navigate, with tools grouped into categories like kinematics, acoustics, light, and magnetism. Now, let me give you a quick overview of the major features. This app is like a Swiss Army knife for physics experiments. There are so many tools. In kinematics, there's a g-force measurement, linear accelerometer, gyroscope, inclinometer, protractor, and a motion visualizer. Under the acoustics tab, there's a sound meter, tone detector, tone generator, oscilloscope, and a spectrum analyzer. Under the light tab, there's a color detector and a proximeter. Under the magnetism tab, there's a compass, magnometer, and magna AR feature. Lastly, the app also comes with a barometer, AR ruler, and GPS features. For this review, I'll focus on the linear accelerometer tool. It measures acceleration in 3 axes, x, y, and z. You can also see a combined graph showing total acceleration over time. Let me show you how I used it in my experiment. For my experiment, I wanted to see how accurate the app's acceleration measurements were. I slid my phone along a 50-inch ruler while timing the motion with the stopwatch. Here's what I recorded. The displacement was 50 inches, which converts into 1.27 meters. Trial 1 took 1.83 seconds, and Trial 2 took 1.82 seconds. Here's what the app recorded during the experiment. For both trials, the app's z-axis, which aligns with my direction of motion, measured an acceleration of about 0.52 meters per second squared. Using the kinematics equation, acceleration in the x equals 2 times x final minus x initial divided by time squared, I calculated acceleration for each trial. For trial 1, the acceleration was 0.758 meters per second squared. For trial 2, the acceleration was 0.767 meters per second squared. The app's measured acceleration of 0.52 meters per second squared is slightly lower than my calculated value of 0.763 meters per second squared. The difference could be attributed to a few factors. One is sensor limitations. The phone's accelerometer might underestimate acceleration consistently. Another option could be noise in the graph. As you can see, a fairly large amount of fluctuations in the data, which could generally be affecting our accuracy. And it's hard to figure out where you should read the graph from. So it could also be due to a misreading of the graph. And lastly, friction could play a role because my experiment didn't account for friction between the phone and the surface, which could reduce the measured acceleration. In addition, it was up to me to keep a constant force on the object, because if I keep a constant force and the mass stays constant, then the acceleration should also be constant, which will allow us to use our kinematics equations. But there's the pretty unlikely chance that I was actually able to keep a perfectly consistent amount of force applied, and so that could also play a role. So despite these factors, the app provides a fairly accurate and consistent measurement, especially for a free tool designed for educational purposes. So let's give a quick summary of the app's strengths and its weaknesses. The pros are that it's free and easy to use. It has a wide variety of tools for different physics experiments. And the accelerometer provides real-time graphs that are easy to read. However, it does have some cons, including its accuracy potentially being affected by sensor noise or environmental factors. It's also not ideal for precise scientific measurements. And some tools, such as the accelerometer, could benefit from having the option to calibrate it better. For example, if the phone sensor is miscalibrated, being able to calibrate it within the app would allow you to increase the accuracy. After thoroughly testing the Physics Toolbox Sensor Suite app, I'm going to rate it 4 out of 5 stars. Let's break that down and talk about what makes this app stand out, as well as where there's room for improvement. So first, what makes the app great? Well, first and foremost, this app is incredibly versatile. It offers an extensive range of tools that cover kinematics, acoustics, light, and magnetism. To put it simply, it's like carrying an entire physics lab in your pocket. Whether you're interested in acceleration, gyroscopes, sound waves, or even spectrum analysis, this app has something for you. I also love how user-friendly the app is. The interface is clean and intuitive, which makes it easy to jump into experiments without wasting time figuring out how to navigate the app. Even the graphs, like the one I used for the linear accelerometer, are clear and easy to interpret, with color-coded data. This makes it an excellent option for both beginners and advanced users who want quick access to data. And let's not forget, it's completely free. That's a huge for students and educators who might not have access to expensive lab equipment or school funding for labs, especially when school funding is being limited. This app democratizes access to hands-on physics tools, and that alone is worth praising. But where it could improve. The app isn't perfect. While the accelerometer performed reasonably well in my experiment, it did underestimate the actual acceleration compared to my calculations. This kind of discrepancy might not matter much for a classroom or introductory level experiment, but it does mean that the app isn't quite as precise as professional equipment. Another issue is the noise in the data. As you saw from the graphs, there were fluctuations and spikes that didn't match the smooth acceleration we'd expect from a perfectly calibrated system. This kind of noise could be reduced with better filtering or calibration feature, which the app currently lacks. Finally, while the app excels in versatility, it's a jack of all trades, but a master of none. It's fantastic for learning and casual experiments, but researchers or anyone needing high precision data may fall short. So who is the app for if it's not for these researchers? Well, in my opinion, it's perfect for students exploring physics concepts and teachers looking for an affordable way to enhance their lessons, as well as hobbyists who enjoy experimenting with their phone sensors. The fact that it's portable and free makes it accessible to a wide audience. That's one of its strongest features. If you're someone who wants to run experiments like the one I demonstrated today, whether it's acceleration, sound waves, or even light intensity, the app will give you the tools you need to get started. It's especially valuable if you don't have access to traditional lab equipment, but still want to get hands-on experiments. In conclusion, I'm very impressed with the Physics Toolbox Sensor Suite. It might not be perfect in terms of precision, but what it lacks in accuracy, it more than makes up for in its versatility, ease of use, and its accessibility. For a free app, it's honestly amazing how much it can do. That's why I'm giving it 4 out of 5 stars. It's not perfect, but for students, educators, and hobbyists, it's one of the best tools out there for learning and experimenting with physics. I had a lot of fun working on this project and testing out the app with my own experiment. I hope this review has inspired you to try it out for yourself and explore its many features. Thank you so much for watching.